Welcome back, everyone. So just to review really quick from what we talked about in the last video, we talked about the Caesar cipher and basically how we go from here's the algorithm, this is how we code it in Python. So just to review Caesar cipher is also known as the shift cipher, basically because each letter in the plaintext is replaced by a letter that you get by shifting down the alphabet. And again, you start with the plain text, you generate the ciphertext, that is encryption, then decryption would be going the other direction, where you start with the ciphertext, the jumbled up version, and you get the plain text back. So that's the Caesar cipher. We're going to talk about one more cipher, and I will bring you through basically the example stage. So you know how on the previous cipher with the Caesar cipher we did a couple of examples and then we talked about, okay, here's some pseudocode, here's the algorithm, and then this is how you can convert the algorithm into Python code. Well, that second part you are going to be doing for your programming assignment. So you will be coding the Vigenere cipher for your programming assignment. It will involve, needing to figure out the algorithm first. So this is one of those programming assignments where you really need to make sure you do that planning stage. If you don't do that planning stage, coding it will be very confusing and likely won't work. So please make sure, first you understand these examples. If these examples don't make sense, please reach out to me sooner than later. Or run through a couple more on your own. And then once those examples are making sense, go ahead and write out pseudocode, much like we did in that practice video before with the Caesar cipher. And then once you have that pseudocode written out, then take each line of the pseudocode and translate it into Python code. That will be your programming assignment. Alright, so let's talk about the Vigenere cipher. So it's similar to the shift cipher, except the key, right? With the shift cipher, the key is an integer. With the Vigenere cipher, the key is now going to be a string. Alright, so it's going to add a little bit more complexity to the previous shift cipher, but it will still be relatively similar. So instead of, with the Caesar cipher where you shifted each letter by, the same amount, like 5, if 5 was the key, with the Vigenere cipher, you're going to shift the letters different amounts. And the amount that you shift the letter by will basically depend on the characters in the key. We'll work within a couple examples and hopefully it'll make sense from there. Alright, so here's an example that we'll work with. So we'll start with the plain text, attack at dawn, all one word because we're not going to worry about spaces. And then the key, again with Vigenere, the key is strings, the key is going to be a word. So in this case the key will be lemon. So this is the example we're working with, attack at dawn and lemon. Alright, so the way Vigenere cipher works is you basically repeat the key so that you have enough characters in your key to match up with characters in your plain text. So for example, in this case, attack at dawn, that has 12 characters. So we'll just repeat lemon a couple of times so that it has at least 12 characters. And then, once you've repeated the key, you then line up the letters. So for example, the character A in attack at dawn will be matched up with the character L in lemon. The character T in attack at dawn is matched up with the character E. T is matched up with M, A is matched up with O, and so on. So you line up these characters, you match them up together, and to do the cipher, first you look up the position of the character, the first character in the ciphertext. In this case, we're going to look up the position of the character A, right? And A is at position 0 in the alphabet, because it's the first letter. Then we also look up the position of the character, of the associated character in the key, right? And we said that A and L are matched up together. So you look up the position of A, which is 0. Then you also look up the position of the letter L in the alphabet, which is 11. If you count starting with A at 0 and you count over, L will be at position 11. So you take these two positions. So now in this case, you have two positions, right? You have 0 and 11. Add them together, and then whatever result you get back, that will be the position of the new character in the ciphertext, right? So in this case, again, A is at position 0, L is at position 11, so 0 plus 11 is 11, which means our new character, our encrypted character, is going to be whatever character is at position 11 in the alphabet. So we already know L is at position 11. This isn't a super cool example because A is position 0, but L is at position 11 in the alphabet, which means the encrypted version of this character, the first character in the ciphertext, with the plaintext attack at dawn and the key lemon, will be letter L. Then we'll keep going through one letter at a time. So the next set of letters we have are T from attack at dawn and E from lemon, right? So we look up those two characters in the alphabet. T is at position 19, E is at position 4. You add 19 and 4, you get 23 back. So that means we then go look up in the alphabet, hey alphabet, what is at position 23? And the character that's at position 23 is the character X. So what that means is that the next letter in the ciphertext will be X. And then keep going, right? The next character in the plaintext is also a T. The associated character in the key is M. T is at position 19, M is at position 12 in the alphabet. Add 19 and 12, you get 31. And we're running into this wraparound issue again, right? 31 is too big for our alphabet. The last letter in our alphabet is Z, which is at index 25. So just like we had to do with the Caesar cipher, you'll want to use the modulus trick here as well. So mod whatever your result is by the length of the alphabet. In this case, our alphabet has 26 characters. So 31 mod 26, you'll get 5 back. That deals with the wraparound for us. So if you wrap around back to the beginning of the alphabet and you count 5 more spots, you will get the next letter in the ciphertext, which is F, because F is at position 5 in our alphabet. So then, as you can imagine, you basically keep repeating this process. So again, the plaintext here is attack at dawn, the key is lemon. So if you're doing this on paper, I generally like to sort of write it out like this as a chart so that it's really easy to see, you know, what letters in the plaintext line up with what letters in the key. And again, the sort of algorithm behind the cipher is you look up the positions of both letters, the letter in the plaintext and the letter in the key, add those positions, do the mod if you need to, look up the new character at this position in the alphabet, and then that's going to be your new character in the ciphertext. So I strongly recommend working through the rest of this example and just making sure you get the exact same ciphertext back, just to make sure that this example is making sense. If you don't quite get the same ciphertext, double check your work. Let me know if you need help beyond that. I'm happy to help with that. Let's do one more example just to make sure we're all on the same page. So given the following alphabet, this is the same standard A through Z lowercase alphabet we've been working with. If I give you the plaintext Thursday and the key CS, what is the encrypted version of that going to be using the Vigenere cipher? So again, plaintext is Thursday, key is CS. Take a couple minutes, work this out by hand, and when you're ready to see the result, come on back to this video. Alright, so hopefully you worked through this and got this as your answer. I will go ahead and step through a couple of letters just to make sure we're all on the same page and to clear up any questions if you have them. So again, here's our alphabet. We are going to start with the plaintext Thursday. And then the key is CS. So again, we are just going to go ahead and repeat that key as many times as necessary so that each letter in the plaintext matches up with a letter in the key. And then we're going to figure out the resulting ciphertext. So again, the rule is you got to go and look up these characters. So we'll first go up and look up the character T, which is right here. And that is at position, let's see, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So T is at position 19. And then C is at position 0, 1, 2. So we'll go ahead and add those. 19 plus 2 gives us 21, which will give us this character V. So the resulting letter in the ciphertext will be V. Alright, next set of characters we have are H and S. H is right here at position 6, 7, looks like. S is down here at position 18, 16, 17, 18. Yep, S is at 18. So we go ahead and add these. 7 plus 18, that is going to give us 25. Awesome, which will give us the character Z. Cool, so that's the next letter in the ciphertext. I'll do maybe 2 more. So next we have U and C. U is right here at position 20. C is at position 2. We add them up, we get 22 back, which will give us the character W, right? Because U is at 20, V is at 1, W is at 22. So this will be W. And then let's just do one more. So R is right here, that's at 16, 17, looks like. And then S, this is an S, not a 5. S is at position 2. Or no, sorry, that's C. S is at position 18. Yes? Okay. So then we have to add these. We get 35 back. Now in this case, 35 is too big. So again, since 35 is too big, we are going to have to go ahead and mod to basically take care of that wraparound. So we'll take the length of the alphabet, which is 26, correct? Because the last character is at position 25, but we start counting at 0. So the length of the alphabet is 26. And we're going to see what the division of this is into 35. 26 goes into 35 one time, with 9 left over. So the result of this division is 1 remainder 9, which means the result of this mod is going to be 9. So we'll go ahead and replace this 35 with a 9. And then look up what character is at position 9, which will be J. Alright, and then obviously keep going through the rest of the letters. If you have questions about any of the other letters, please do let me know. But hopefully, if you had any confusion, this example cleared that up. Alright, so again, that's the Vigenere cipher. So for your programming assignment, you will code it. So you'll code both encryption and decryption functions for Vigenere. As you saw in the previous example though, once you get the encryption one working, the decryption one is just a matter of basically reversing the math and replacing a couple of variable names. Again, strongly recommend focusing on the algorithm first, so make sure you understand the algorithm. You know, go through maybe a couple more examples on your own, and then do that design and planning phase, much like we did for the Caesar cipher. So make a plan, pseudocode, flowchart, whatever works for you before you work on the code. As usual, if you have any questions, feel free to let me know. Otherwise, I'll see you all at the exam, because this is the last video. This is the last content for this course. So congrats on making it this far, and I will see you all soon.